How are you, my friends? This is lecture 37 of the pre-calculus course about parabolas, conic sections. When we see these graphs, the parabola, circle, ellipse, and hyperbola, we call these conic sections. I will show you in the next slide why we call them conic sections. These graphs are coming from the intersection of a cone and a plane. So we can see here, let's start with this one. If we place the plane with the intersection with the cone, we have a circle here. We have studied this circle in the algebra course, lecture number 20. We can have in the intersection an ellipse if we place the plane like this. So this will be lecture 38 of the pre-calculus course. Now we are studying lecture 37. This is the parabola, the intersection of the plane in this position with the cone. And the last one will be the hyperbola, lecture number 39. And also lecture number 40, which is the last lecture in this course, pre-calculus course. So in this lecture, we will study the vertical and the horizontal parabolas, geometric definition of a parabola, and the equations and the graphs for sure. Some review formulas important in this lecture. The midpoint formula we know, x1 plus x2 over 2, y1 plus y2 over 2. Just to remind you of that. Distance formula also, d will be the square root of x2 minus x1 squared plus y2 minus y1 squared. Distance between any 2 points. This is a special distance formula where we have 2 points on the horizontal line or a vertical line. Then we can take the absolute value of a minus b, which is the same as absolute value of b minus a. Now, parabolas are divided into two types, the vertical and horizontal parabolas. From the complete algebra course, please, you can see the lecture number 34 about quadratic function. We have seen this parabola opening up or down, that's a function. And the standard form was y equals f of x, a x minus h squared, plus k, where the vertex is h and k, and the axis of symmetry is x equals h. Now, in a similar way, we can find that the horizontal parabola has a standard form, x equals a, y minus k squared plus h. This is not a function, it is a relation. The vertex here is h and k. Let's see, graph the parabola and give the domain and range of this equation. Y plus 4x is equal minus x plus 3 squared minus 15. The first thing we have to do is to rearrange the equation, expand it, simplify it, put it in standard form. The standard form is f of x, as I mentioned before, ax minus h squared plus k. So we have y plus 4x. This one we have perfect squared, x squared plus 6x plus 9. There is a minus outside. Simplify everything, you will get f of x minus x squared minus 10x minus 24. This is a general form of quadratic function. So there are two ways we can find the vertex and the standard form. One way is h is equal to minus b over 2a. So this is minus 10 over 2. A is minus 1, it will be minus 5. Replace minus 5 now in the function. Here we will get k. So k will be f of minus 5, which is 1. You can do that and check the numbers. So the vertex will be minus 5 and 1. This is one way we can find the vertex. Remember, vertex is h and k. Now also you can find the vertex by completing the square, which I have mentioned in the algebra course lecture number 34. Well, here we have the standard form of the function. F of x is minus x plus 5 squared plus 1. This is a parabola reflected in the x-axis with this minus, shifted on the left 5 units and shifted 1 unit up. So we can see the graph here is like that. So here the domain is all real numbers and the range from minus infinity until 1 closed. So the axis of symmetry is x equals minus 5. Now for x-intercept, I advise you to use the standard form because it's easy. X-intercept, let y equal 0. Use the standard form here, put y 0. Then you can find x plus 5 is equal plus or minus 1. So x will be minus 6 or x will be minus 4. For y-intercept, easier, use the general form. Just replace x by 0, you get y equal minus 24. You can see that it's down, 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 down here, the y-intercept. Now another question similar, x equals 2y squared plus 6y plus 5. This is another parabola, horizontal. Let's use here completing the square. So to complete this square, we need the coefficient of y squared, remember, is 1. So I take 2 here, common factor. I leave the 5 here. You see the 5 plus 5 plus 5 plus 5, and then I will add it at the end. So I have now y squared plus 3y. I need to complete the square to make it perfect. So I take the coefficient of y, 3, divide by 2, 3 over 2, square it. So that's 9 over 4. So I add 9 over 4 and subtract 9 over 4 as if I'm adding 0. Now I take the first 3 terms here. It will be y plus 3 over 2 all squared minus 9 over 4. Then I multiply by 2 again. So 2 times this bracket, 2 times this becomes minus 9 over 2, plus the 5 becomes half. So we can see the vertex now. This is the standard form of the horizontal parabola. So the vertex will be half and minus 3 over 2. This is the general form. And this is the graph opening to the right. The domain will be from half until infinity, and the range is all real numbers. Now, this is a geometric definition of a parabola. What is the meaning of a parabola? It's so interesting. A parabola is the set of all points. See, like these points here, M, N, V, B, A, any point on the parabola that are equidistant. Equidistant means the same distance from a fixed point called the focus and a fixed line called directrix. So simply we have a focus here, F focus, which is a point fixed. And we have a line called directrix, also fixed line. Find all the points that have the same distance, like A. See A has the distance AF, same as AL. So A on the parabola. B, BF, the same as BL on the parabola. MF is equal to ML. VF is equal VL. Every point on the parabola, the distance from that point to the focus, the same as the distance from that point to the directrix. So now we need to derive the equation. So we can take any point here, A, X, Y, and the focus is 0P. So this is the P here. P means the distance from the focus to the vertex. Let's find a point here on the directrix. Directrix is the line. So let's find a point here, which is X minus P. Okay, so we say the distance from A to F is equal to distance from A to D. This is the point D. Just apply the formula of the distance, x2 minus x1 squared, y2 minus y1 squared, and then square both sides and simplify. See, try to do it by yourself, please. I wrote here everything you need until we will cancel everything. We will get x squared is equal 4py. So the equation now for the parabola opens upward or downwards. It will be x squared 4py. This is the same equation here. I said remember. Now the information you need for this function is the vertex 0, 0, and later we will see the vertex h and k. But now we will take the vertex 0, 0. Focus now 0p. Focus here. So the focus always is inside the parabola. So this is the parabola here, and the focus always inside. Any parabola, the focus is inside. Directrix y equals minus p. Remember, distance between focus and the vertex is absolute value of p, which is always positive. Axis of symmetry, x equals 0. P positive here, if p is positive, it opens upward. If p is negative, it opens downward. Same thing we can derive for the other parabola, which is horizontal parabola. This is not a function. So try to remember y squared is equal 4px. So if squared on the y, x has power 1, then the parabola either opens to the right or to the left. If we have here, let's go back a little, x squared and y has power 1, so the parabola opens up or opens down. And these are the information you need for focus. Let's say the focus is P0 because it is on the x-axis and the vertex is 0, 0 here. Now let's find the focus and the directrix of the parabola whose equation is this. X minus 4 times x plus 2 equals minus 2x plus 4 minus 4y. How can we find the focus and the directrix? The important thing is to find P. To find P, we have to write the equation as x squared is equal something y, or y squared is equal 4 something x. In both cases, we have to rearrange this equation. So let's go. Multiply here x squared plus 2x minus 4x minus 8. So it becomes x squared minus 2x minus 8. Here we distribute the minus 2. Simplify, we will get x squared is equal 8y. See, that's the equation now. Just go to the formula. This is a fixed formula. X squared is equal 4py. If you compare this with this, x squared is the same, y is the same, 8 is 4p. So I put 8 equals 4p. So p will be 2. Positive, that means it opens upward. If p is 2, that means the distance between the vertex and the focus is 2. So I can write focus 0, 2. Remember, focus is a point. Directrix is a line. So the distance now from V to the line is 2, but it will be down here. So y equals minus 2. That's a straight line horizontal. Another example. Let's find the focus and directrix of this parabola. I advise you to pause the video for a little and then try it yourself. Find the focus and the directrix of this equation. Rearrange it first, and when you are ready, let's go to the solution. So I expand here y, and then this y squared minus 10y plus 25 becomes minus y squared plus 10y, because there's a minus in the middle here with this minus, and here we have plus 25 with this minus outside becomes minus 25. This is 28x plus 10y minus 25. Simplify everything until you get y squared is equal minus 28x. Now compare this with the horizontal parabola. This is the equation, fixed equation, y squared is equal 4px. Now minus 28 becomes 4p, divide by 4, p will be minus 7. Remember, p is negative, and we have y squared. So that's a horizontal opening to the left. And inside will be the focus. So now the focus will be minus 7, 0. Directrix will be on the other side, x equals 7. Now let's look at example 5. Find an equation for the parabola with focus 3, 0 and the vertex at the origin. So this is the opposite of example 4 and also 3. Here we have to find the equation. I advise you, when you have a question like this, find the equation to do a little sketch. So let's take here the focus and the vertex, everything given, and then make a little sketch. So the vertex here is 0, 0. We know the focus is inside the parabola, so f would be 3, 0. This is the axis, so I know the equation I have to use is y squared is equal 4px. So I start from there. I know also the distance between the focus and the vertex is the p, so p will be 3 positive because it opens on the right, and the directrix here is x equals -3. So I can just write the equation directly. Y squared will be 12x. That's easy. Another one, find the equation for the parabola vertical axis of symmetry, vertex at the origin, passing through the point, square root of 3, 3. So we have here different given. So I can make a little sketch also for example number 6. The vertex is 0, 0 here. And there is a point on the graph. See this point, square root of 3, 3, positive x, positive y. So this is in quadrant 1. So that means it is opening up. So I can use the equation x squared is equal 4py. Now to find p, see, I don't have any idea about the focus here. So what can I do? Smart way. Put x is equal square root of 3. Y will be 3. So I replace them here in the equation. See, I replace square root of 3 is the x here. And then y is the 3. So p will be 1 over 4. So this is the basic function, x squared is equal y. We have seen this function in the algebra course, lecture number 34. F of x is equal x squared. Now the focus is 0 and 1 over 4. The focus is here, just 0.25, far from the vertex. Now let's start the shifted parabolas. Same idea, guys, here. I put here on the side, remember when the vertex is 0, 0, this is what we have explained in the first 6 examples. When the vertex is 0, 0, the equation is x squared equals 4py. The same equation here. Now the vertex is hk. So I put h always related to x and k is related to y. So we have x minus h squared is equal 4p y minus k. Same equation with shifted vertex. So the vertex now is hk. Now the focus, it was 0p at the beginning without shifting. So it will be 0 plus h, p plus k. And the directrix, it was y equals minus p only. So we say now y equals minus p plus k. And the axis of symmetry will be x equals h. Same rule here. If p positive, it opens up. If p negative, it opens down. Remember, this is a function because we have the squared on the x. Same thing we can say for the horizontal axis of symmetry, the horizontal parabolas. The equation was y squared is equal 4px if the vertex is 0, 0, remember. If we change the vertex to hk, what will happen? Y minus k squared is equal 4p x minus h. It opens to the right if p positive. It opens to the left if p negative. Same idea, the vertex is h and k. The focus was p0. Now it is p plus h, 0 plus k. The directrix will be x equals minus p plus h. And the x is y equals k here. Now let's see this nice example 7. Find an equation for the parabola with vertex 1, 3 and focus minus 1, 3. Do you remember the advice? The first thing we can do before we find the equation, before we graph it, before we find the domain, the range, the equation of directrix, the axis of symmetry, we make a sketch for number 7. V, the vertex 1, 3, I write it here. The focus is inside minus 1, 3. So that means the parabola opens to the left. That's we know from the sketch. And we know the equation also, squared on the y, that's horizontal parabola. Y minus k squared is equal 4p x minus h. So we can proceed now. So from the sketch, we can know that the parabola opens to the left. Now, what is P? Remember the definition? P is the distance from V, the vertex, to the focus. So it's absolute value of 1 minus 1, which is 2. So P is 2 as a distance, but since it opens to the left, we have to write P equals minus 2. Now I can write the equation here. I know the vertex, this is 1 and 3, that's H and K. And I know P is minus 2, so I can write now the equation here. So y minus 3 squared is equal minus 8x minus 1. This is the equation. You can write it any way you like. You can expand it. You can leave it like this. You can write it as x equals something. Now the axis of symmetry will be y equals 3. The directrix from the formula, x will be minus p plus h. So we can write minus, p is minus 2 plus h is 1. X equals 3, domain minus 1, infinity to 1, and the range is minus infinity to plus infinity, or real numbers. Now, focal diameter, we need to define a focal diameter. Now, let me start here. The line segment through the focus, see the focus here? P0, see this is F. The line segment through the focus perpendicular to the axis. So this yellow line here, you see this yellow line? That's the line segment with endpoints on the parabola. So we have this point and this point on the parabola. It's called latus rectum. This one here, the yellow line. Its length, the length of this yellow will be called focal diameter, FD. Now the focal diameter will be the absolute value of 4P. How do you find that? Let's take the focus here, FP0. If we draw this line, that means there is a point on the parabola here where x is P. So I can write the equation, y squared is equal 4px. Then I replace x by P. So it becomes y squared is equal 4p squared. Take the square root of both sides. Y will be plus or minus 2p. So now this line is 2p here. And I need this length here of this line segment, which we call it focal diameter, which is like a diameter through the focus in the parabola. Now this one, the focal diameter, is used to determine the width of the parabola, how wide. Because if the P is a big number, like 5, 6, or 7, 10, whatever, we know that the parabola is wide. If P is small, the focal diameter is small, that means the parabola is narrow. I will show here 4 examples where we have P is 4, P is 1, P is 0.5, P is 0.125. So we have different functions here. All of them are parabolas. So the whole idea here, if P is large, big number, then the parabola is wide. If P is small, then the parabola is narrow. Let's look at this nice example. Find the focal diameter of the parabola. 12y plus 1 is equal to x plus 1 minus x plus 1 squared. For sure, we have to rearrange it until we get P, correct? You can do it if you like, and then you can check. So when you expand this, you will get 12y is equal minus x squared. So just compare this with x squared is equal 4py. So here you have to multiply with the minus 1 to make it similar to the formula we know. So minus 12 will be 4p, p will be minus 3. See the squared here on the x, that means the parabola either up or down. We have negative p minus 3, the value of the p, so it opens downwards here like this. And the focus now is 0 minus 3, that's the focus here. Now the focal diameter, FD, will be absolute value of 4p. 4 times the p in the absolute value becomes 12. 12 means this is the distance here. See the length here? This red line, that's the line segment has a length of 12, focal diameter. Write the equation of the parabola y squared minus 8y plus 4t is equal minus 12x in standard form. After that, you can find anything you like. You can find the vertex, the focus, the directrix, the domain, the range, the x-intercept, y-intercept, the graph. Now, remember, anything we have to write in standard form when we have squared on the x or squared on the y or both in other conic sections, as we'll see later, you have to complete the square. So the whole idea here, rearrange the equation by completing the square. Remember, completing the square, you have to have the coefficient of y squared or x squared 1. If it is not 1, take out that number as a common factor. So now this is y squared coefficient 1 minus 8y. Take minus 8, divide by 2, minus 4. Square it, 16. So plus 16 minus 16 plus 40. So the first three terms becomes perfect y minus 4 squared minus 12x. Here we have minus 16. See, the plus 16 goes with the factoring. Minus 16 plus 40 on the other side, it's minus 24. Take minus 12 out, so x plus 2. So minus 12 is equal 4p, according to our equation here, the formula. So p will be minus 3. So we can write the vertex, h and k. Remember, the vertex is minus 2 and 4. Minus 2 and 4. This is the vertex. Focus, that's the formula. It will be minus 5 and 4. Directrix, this is the formula. X equals minus p plus h, and the axis will be y equals 4. Now in this lecture 37, you find two parts for practice questions, please. Part number 1, there are 5 questions, and part number 2, there are 8 old exams questions for you to practice. The first 5 here, part 1, will be in one video, the solutions, complete solutions, and part 2 will be in another video, 8 old exams questions. Let me show you now the first 5 questions. Part 1. This is the question, so nice. Find an equation in standard form of the parabola that has vertex minus 1, 2, horizontal axis of symmetry passes through the point 6, 1. Try it, see the formulas, and then you can check the answer. Question 2. Given the quadratic function f of x is equal, f of x means y, guys, here. F of x means you can write y equals 1 over 8x squared minus half x plus 3 over 2. Find the focus and the directrix. Question number 3, find the vertex if the graph of the equation here, all this, see, all this 4x minus 1 squared plus y squared plus 4x minus 2y plus 2m minus 1 times x squared minus 11 equals 0 represents a horizontal parabola. Remember, horizontal parabola, we should have y squared and no x squared. Horizontal means y squared. This one is easy and not easy. You can check it later. Find an equation of the parabola. We have a parabola here, easy. The vertex at the origin, 0, 0. But we don't have the focus. There is a point here, focus. And then there is a line here, passes through the focus. And this line has a slope half. Also, this point on the parabola, the x is 2. This is everything given. The slope is half. There is a focus here, 0p maybe, you can write it. And there is a point here at 2. Try to figure out how do you find the equation. Okay. Now, number 5, if 3k is the vertex of this parabola whose equation, 3x squared plus 2mx plus 8y is equal minus 24. Find the value of k. Remember, there is an m here and there is a k there. So be careful. Now, these are the answers, only the answers, 1, 2, 3, 4, and 5. For complete solution, part 1, you can see the video, please, on parabolas, conic sections, 5 solved questions. Now, part 2, we have 8 old exams questions. Number 1, graph the parabola and give the domain and range. This is easy, I think. Find the vertex of the parabola here and find also the domain and range by any method you like. There are 2 ways. Find an equation of parabola with focus 1, 3 and directrix x equals 3. Also, there is a similar example in the lecture. Given the equation of the parabola 40y minus 82 is equal to 2x squared plus 4x. Write it in standard form, then graph it, then find the vertex, focus, and the equation of directrix. This one is a medium question, maybe. Find an equation of the parabola with vertical axis, first thing, vertex 6 minus 4, and passing through the point minus 2, 12. Find also the focus, directrix, and graph it. Question number 6, given the equation of the parabola, 2y squared minus 23 is equal to 32x plus 12y plus 23. Write it in standard form, then answer these questions. So you have to complete the square, remember that? Find an equation for the parabola with vertex m and then 2 plus m over 2. That's the vertex, like hk. Opens downwards and passing through the point 1, 3, and it has focal diameter 8. So you have to take all this information, 1, 2, 3, 4 things you have in the given, try to find the correct equation. And number 8, if the equation of the parabola with vertex 1, 2 and x-intercept 3 over 2 is written in the form x equals ay squared plus by plus c. Find the value of a times b times c. Okay. Now, these are the answers of the 8 questions. For the complete solution, please, you can see the video on Parabolas Conic Sections, lecture number 37, Pre-Calculus, all the exams questions. Thank you for watching. If you like the video, you can subscribe and share it with your friends. Just to remind you, this is Pre-Calculus course, lecture number 37, and we are reaching the end of the course, which is lecture number 40. I hope I can see you in another video with another topic. Thank you for listening, guys.